Hello. Today I want to have a introduction to my FastIO library because a lot of people they say they want to understand what the library is doing and what's the overall design of the library and what the library is trying to solve, right? Particularly if using any libraries, you want to know why why the author is trying to make that library, what kind of problems it tries to solve, and what's the benefit it can give you. So before we talk about why I create this FastIO library, we need a background. And so what's the real world problems the library tries to solve, and what's the current problems with our current existing solutions, and why we believe, including I believe, right? It's just I believe, but other people will agree with me, so I say this: we believe C++ standard library needs a new IO library. So the problem is that C++ Iostream is widely banning C++ projects. Many C++ code guidelines ban Iostream, including compilers, right? Gaming industries, they of course ban it, particularly this EASTL stuff. EASTL, they ban Iostream too. They are not actually, they're just writing standard library, reading containers, for example, right? They don't touch IO, but they also ban Iostream. Not just that, but other industries like Wall Street, like in financial industry, like Wall Street, like Chase Bank, they all ban Iostream, So for example, we can see ILVM. I think I can show you this ILVM code guideline. It's just not one. Just GCC does the same thing, This explicitly said include Iostream is forbidden, They just directly tells you include Iostream is forbidden, and they said we provide our own implementation, simple and efficient implementation with Iostream. They have similar functionalities, but it's forbidden. Iostream is forbidden, and for example, we can also see what GCC is doing, and GCC do the same thing, right? They just we will continue to use printf function style functions instead of Iostream functions. So Iostream is widely banned, It's widely banned. So I actually did an unofficial survey because just these people are saying doesn't mean they actually banned it, right? But I actually did an unofficial survey on it. This survey is not accurate, just some simple survey. And we can see that I'm asking whether Iostream is allowed in a project, So, I'm sorry, just you cannot see that. When I can just copy that graph here in some. Okay, probably not. So we can see half the C++ projects by Iostream. You might say the sample size is too small. Yeah, the sample size is very small, but I just want to take a simple response. I want to see a simple graph where it matches out my guess. Yes, at least this guidelines shows you that they actually ban Iostream, right? Even compilers ban Iostream, right? If the compiler teams ban something we are using, then that stuff must be wrong, right? If that stuff is so good, why compiler vendors themselves ban it? This is their own stuff, but they ban their own stuff, So, and of course, the Biani, the Hubsat are not happy with the situation. They actually said in C++ code guidelines, we can see the C++ code guidelines, I think I put it here, right? So they said we provide streams for IO. Okay. They said if we need IO performance, you can always do better than printf. The STDIO are security hazards, and their argument is STDIO are security hazards, and usually Iostream for security purposes, but they don't actually solve problems. The problem is that Iostream is too slow. Yeah, I can always do better when I'm printf, but why standard library does not provide that, right? So if standard library explicitly said prefer IO streams for IO, that just directly tells you there's something very wrong with it. You just design very poorly. I think Iostream is notoriously being bad. You know, a lot of people don't like it. Many people just even ban this language. They don't want to use this language anymore because C++ Iostream. They don't like C++ Iostream. They heard that it's too slow, and they don't like the operator overloading solutions either. I don't either. I don't like the operator overloading solutions. But Iostream did a lot of right things. We can talk about it. But you can see the situation is very like C++ exceptions right now, right? C++ Iostream is largely banned. You know, it's not just one or two projects. You can see even the compiler teams banned it. I think I can show this was in a Wall Street post saying C++ Iostream is considered harmful. You know? They actually said C++ Iostream considered harmful, but this unfortunately LinkedIn I cannot open it anymore. It's dead. The page is dead. I'm sorry. There's no just if anyone can just yeah. So never use but you can still see something here. Never use Iostream in production code. You know, because the performance is too bad. You know. So Iostream is widely banned, and we keep creating dialects for doing what Iostream can or should do, while they create a lot of mess, new mess, for example. Of course, one example is C++ file system. It is poorly designed. You know, the first problem is, of course, particularly from the security perspective. So C++ Iostream suffers from the TOC/TOU problem. You know, TOC/TOU is one kind of zero-day vulnerability, and you can check that with time to check and time to use, time to check, time to use, time to use, or time to check to time to use, not time to check and time to use. Okay. Time of check of time to use. Okay, I'm pronounce that again. Time of check and time of to time of use. Okay. So Iostream suffered from TOC/TOU problem. The POSIX actually provides some new APIs like OpenNet, for example. But unfortunately, C++ Iostream does not provide like APIs. So C++ 17.5 is basically standardized the buggy part of the POSIX. Iostream fundamentally, the problem is that C++ WG21 ignores POSIX, right? So it just ignores POSIX. And Iostream cannot play the role as POSIX file descriptor can play, right? You cannot get file descriptors from Iostream. You cannot construct an Iostream with file descriptors either. And there are some functionalities of FileStar that Iostream does not provide. Some open mode like xflag. So Iostream cannot play the role as POSIX file descriptors can play from C++ language level. And there are other issues with of course we heard from Hopsara mentioning the role of deterministic exceptions that they promote two X interface and binary block. So the C++ 17 file system, we can just check those APIs. You know, the CPP reference, the entire CPP reference is basically teaching people how to write vulnerabilities. You know, how to write zero-day vulnerability. You know, this kind of code is already some kind of zero-day vulnerability. Basically, all the C++ 17 file system is a vulnerability. You know, the library is poorly designed, and it's ridiculous, to be honest. And this operator overloading abuse, this abusive operator overloading. No, it's a separator. A separator is not a. It's a part of nonsense, you know. And I mean, people just don't understand how things work. You cannot use a separator here. A separator is nowhere portable. We don't need separator. And of course, the best example we want to show is this increment and pass, you know. The second API took an increment, but it's not no except. It's not no except. Because bad luck may throw, you know. This is ridiculous. It can throw bad luck. It can throw bad luck. So it's not marked as no except. No except remove. This is a bad API, you know, just completely bad. The API is bad. Allocation failure is horrible, you know. Just they make this horrible mess here, which is entire C+17 file system is a mess. And if you have the TOC, TOU, it's a security hazard. Same story happens with C+17 kconf. The extra bound checking, just contract violation, right? You add more potential issues like exception safeties, because when you deal with errors, you get through exceptions, and you have potential bound checking issues. Even in error code, you might have exception safety, similar issues with it. Like you might do double free with the code path, for example. I think that happens a lot in Rust code. And you know, due to the bound checking, you know, it's very hard to implement efficiently. You know, the problem is that, for example, you're writing this dragon box or this Rui algorithm. This algorithm, they don't know the set size, you know, how much size you need to allocate before they run the algorithm. You know, they have to first run the algorithm, then they know how long it is. But C+17 kconf is designed in a way that it's impossible to implement efficiently. Because of the bound checking here, you know, it's not minimum interface, and because of the bound checking for contract violation, it's just abusing exception the error code mechanism. Of course, it has other issues, like it doesn't play with other C+ high-level abstractions very well. For example, it cannot use for constructing strings through string. Just no W. Of course, it has no wchar. wchar80, char16t, or char32t support, and does not play very well with I/O interface. So the C+17 kconf is a huge mistake, in my opinion. It just designed very poorly, and people who propose it. The problem is that it just try to avoid using Iostream. It's just another Iostream dialects. They don't want to use Iostream, but what they end up is giving you crap like this. It's not even efficient, you know. So kconf performs extremely bad compared to third-party implementations. So it's bad. It's just bad. It's bad implementations, bad APIs, and you have no reason to use it in general. And it doesn't work with EBCDIC in execution char set either, if you're not using ASCII-based character set. I don't know how that stuff could work on ABACIDIC. I think they just don't work, particularly with all these mainstream C++ implementations. They don't work, you know. They just don't work. The C+20 format or GitHub FMT lib, it's just a horrible mess, you know. These issues exist in these safe languages like Project Verona. It's just funny, you know, these so-called memory safe languages. It's creating new memory safety issues in their code because of using this FMT lib with just to print string. So no, the people tell you if FMT is type safe, and no, it's not type safe. Neither is zero overhead. It's not zero overhead, you know. Zero overhead or zero cost is such an abused term in today's C++ community. Or I think Rust community is probably abusing that term in a larger degree. But there are no zero cost abstraction. There are no zero overhead abstractions. You know, they all have the overhead. You know, even FastIO has overhead. You cannot say FastIO does not have overhead. It's just dishonest. So this is wrong. It's just completely wrong, you know. And people tell you it's type safe. No, it's not type safe. You can easily attack it, just like attacking C style printf function. You know, you can just read a string and you see the string and then you print it. And then your program crashes, right? You might say it was through exceptions, right? No, it's through exception does not make you safe, right? They might just want to use the exceptions to double free on some resources and to attack your program. It's not necessarily safe, you know. And there are issues which does not exist in printf function, but in the FMT print, you know. What you can do is this: you write, if there's some people write code like this, it doesn't. It's very dangerous, you know. You can just input this. You just input 0, 1, 1, 4, 1. Just input this, you know. It will allocate a very large string. It's a format string vulnerability. What is okay? What I don't. I'm sorry. Just this will hit the overcommit mechanism, and the OS won't kill. Will just kill your process, leading to denial of service. It's impossible to. It wants through exceptions. Okay, this code wants through exceptions. You will see a killed by operating system kernel, because you allocate too much memory, and that will overflow. You know, that will hit and overcommit of the operating system. You're mining on another machine that will allocate a very large string, and you get it hung. You know, even with 64 gigabytes of memory, you will still, no matter how large your memory is, it will find a hit and overcommit. So it's not safe, you know. And the double format string is another example which is not existing with the stdio. You can double print str. And this is ridiculous, right? If you think of it, then you import this. You have this is double print, you know, double print, and through exceptions. And I will argue through exception is not a solution for contract violation, right? The add method is historical mistake, right? This is a contract violation. Contract violation should not through exceptions. That's why C++720 span has no add method, because it's contract violation, right? But C++720 still introduces two format error, you know, which is self-contradicting. You have part of standard library, a new standard library is using add deal with contract violation with exceptions, others are not. Which is ridiculous, right? C++ finally realizes the problem, but they still make that kind of mistakes. You know, just directly make that mistakes. Yeah, you can just directly see their mistakes. Which is self-contradicting. It's hard to sanitize format string before using, you know. Even you sanitize it, whether. Okay, I think I'm recording. I hope I'm recording. I think no problem. Even you sanitize a format string, the incorrect use of format string will still lead to vulnerabilities. You know, you will still have vulnerabilities with format string. Right? How do you sanitize? For example, how do you sanitize? You might be able to sanitize this is an illegal format string, but an incorrect usage of format string like this, even though the format string is correct, it will still get crash, right? So it's impossible to, even after you sanitize it, incorrect usage will still lead to vulnerability. So if we look at the history, you know, format string is a historical mistake, you know. Historically, it's a security hazard. We can see this CWE here. You know, it can lead to buffer overflows, denial services, or other representation problems. It just might not, in some cases, like internationalization, they might not pose a vulnerability, but I think this is not the case for C++20 format. People is abusing it, and we have seen that in Project Verona. You know, Project Verona is, they actually did this. It's just FMT comprint. You know, they actually did this. You know, this is their code. And they actually do this. You know, there's no reason they did this. You know, why do you not use string string? There's no reason to do this. So this code is bad, and then they should feel bad, you know. And you know, people would argue that and also implementation is extremely buggy. I just checked the GDBC implementation of format string. The GDBC is probably the most efficient format string implementation in the world. But you can see that just go to a bunch of just go to, just code is completely unreadable. Just this format string is completely unreadable, and they are very inefficient. Just all these go to, they're just in the happy path, in the critical path. They are not efficient at all. Just very bad in my opinion. And it has type pointing, this undefined behavior, right? You cannot just typecast a pointer. I don't know whether they just put alias in here, but generally just a bunch of undefined behavior, I think. And you have people abusing it for it. So historically it's a mistake. And I think there's actually a paper talking about format string. I think I don't have time to show you here. They actually show that printf function is the largest set of the vulnerabilities occurring in all C and C++ memory safety issues for all C++ and C++ projects. So using format string is very, very bad for the security of C++ too. Also, it makes the complexity, it makes things very complexity, it's very to implement it efficiently, and you cannot avoid the binary bloat with it because you have to introduce entire runtime behind the format string. It's just impossible to implement that efficiently, Garbage collection, people will say, oh, every language has it, The garbage collection was assumed to be a very good idea, but nowadays you see all new languages, you just avoid for garbage collection, including Swift, Rust, Zig, V language, for example. The same will apply to format string. Right? People will finally realize it's a horrible mistake, and I foresee the future. I think 10 years later, people will agree with me. Format string is a mistake. Using format string is useful, like the CW is saying, but I would argue the functionality must be restricted. Likewise, floating precision should not be part of formatters. First, you make things very complex to parse. Second, it is not just for localization perspective, I think. You cannot make, I think using floating precisions or some kind of other stuff, you will never be able to satisfy it. Right? It's a sub-language. You find that I will never be able to, this functionality is still not enough. I'm going to keep doing this. This happens with a lot of other languages, and probably in Python, they have a very serious issues with format string vulnerability. So format string vulnerability is not just a C++ issue, not just C or C++ issue. It's a widely spread issues across all the languages. Rust forbids runtime format string, but the performance isn't good either because it's still built on top of format string. Fundamentally, implementation doesn't change. The complexity does not get removed. The Rust IO performance is also very terrible. Rust is also a horrible language. What a horrible language is Rust, and which is ridiculous. Let's talk about C++ 23 networking TS proposal. The problem is that there's no cryptography, No cryptography, Fundamentally, 95% websites are HTTPS, Even C++ 723 added to the standard library, it cannot access internet, And it only supports TCP or UDP. However, POSIX supports a lot of other address family or protocol families. Bluetooth, for example, probably we have future 5G protocol family. So how does this interface going to support these things? You finally realize that just nothing works, Of course, I have legality issues because you don't have cryptography. The European Union law does not allow any network connections to be released. I think just sorry, I think I did things wrong. I used the wrong words here, but just basically European law forbids releasing network products without cryptography. And also we have to think about these stuff like DNS over HTTPS. DNS server will use HTTPS in the future too. What you can do with it? You have no cryptography, right? Fundamentally, just another Iostream dialects. They're just file descriptors from operating system perspective, and you have no way to fix it. And you have also this async I/O. It only works for networking. It doesn't work with the original files. You have the abstraction problems, because fundamentally, they are all from if you're operating system kernel, you see through this. You see if you're all kernel, you see all side. You see the user space. What I find is that Iostream and networking are doing exactly the same thing. They just call syscalls on file descriptors. They don't actually do something different. So that's something the Iostream did very wrong here. And you might say, we can use just using OpenSSL. I'm not saying OpenSSL will always does not work. I just think it does not work for Open Network TS. The reason is that OpenSSL itself is another I/O library. It has its own OpenSSL BIO. By using this, we just technically add another I/O library hidden in C++ standard library, promoting more binary bloat and adding more attack surface for attacker, because now you introduce more code in your binary. You cannot say putting in the shared libraries and it does not bloat. Shared library is a terrible idea, because it provides this attack surface. It doesn't share code. Don't listen to people share code. Even Libc, they don't share. They don't share code. The recent security papers show that only 5% of less than 5% functions can be shared with Libc. It just doesn't share code in general. The OpenSSL is bloat, and it doesn't work with, for example, with freestanding environment or bare metal systems, or with a modeling environment. We have binary size restriction. So if I want to use cryptography inside the operating system kernel, I cannot use the OpenSSL, right? That's why you can see all these operating system kernel, they just use their own cryptography library. Every operating system kernel recreates their own cryptography library because they cannot use OpenSSL, And recent security paper is also worrying about this low-end embedded device. It does not compare any cryptography support because they cannot implement that, right? Not everyone has the knowledge to implement cryptography. So, right? So, which is ridiculous, just ridiculous. Of course, the most important slide is, like I said, you add another I/O library inside I/O library. Add another Iostream dialect, just another Iostream, basically. OpenSSL BIO. And they actually have a bunch of BIO printf CVEs, CVE with memory. They actually replace the entire STDIO with printf, and they have the CVE10 level, CVSS 10 levels of printf with printf BIO printf functions. They don't use STDIO, They just ban that standard library. They have these problems with it. Of course, they are the people. OpenSSL is part of the issues. They need to be blamed, but also C and C+ community is another part of the problems, right? Why do you create these problems that people have to use their own I/O libraries, create their own I/O libraries for their certain needs, right? That means we have to do something. I don't think OpenSSL, this wrapping existing third-party library solution, would work but have that TS. And we can apply the same story to other proposals like process TS or some TS. They are all Iostream dialects, right? For example, I'm writing a multi-process server. I need to redirect STD in, STD out. It has to deal with Iostream in some form. But multi-process server, for example, I'm creating multi-process server. You might say, why do I need multi-process server? I want to create microservices. For example, I want to create an VPN server or proxy stores like virtual children, for example. I want to use them use them as a proxy. I don't want my server to crash, but multiprocess server, you don't have multiprocess server, which is ridiculous. You cannot use them. It just doesn't work with existing Iostream facilities. Then we create another in-out whatever nonsense, just to represent 5 descriptors, and it doesn't work very well. I think they also have the TOC TOU with it, just like I mentioned with STU file system. Some reason it's just similar, particularly from the kernel driver perspective. You're using IO control. This is not an Iostream dialect, so which is very bad in my opinion. You're just creating another Iostream dialect. The LLFIO, I actually don't like the term. I think low level is an abuse term. It's very confusing. But the problem is that it's just another Iostream dialect. It cannot replace Iostream, right? You still have to use Iostream with it. And people say, oh, I will still use Iostream, right? I won't use your LLFIO. Iostream works fine. Why do I need LLFIO? It just makes my code very hard to write. It doesn't work for bare metal system either, because it requires an operating system. It requires an operating system. I think it probably requires dynamic libraries or whatever nonsense to work. In general, it doesn't work in bare metal operating system either. So, of course, we're going to talk about Iostream itself, because we just talk about these Iostream dialects. They don't work. And I think the fundamental problem is that Iostream is a tragic object-oriented programming. All these failed C++ features are all OOP. The OOP are the reasons why these like EH, RDG, Iostream failed. So O is the reason why they failed. So of course the first problem is that Iostream is extremely bloated. Iostream is bloated. Just include Iostream blows binary size for 800 kilobytes. It's completely unacceptable for security by the embedded system. The problem is that the compiler do not remove dead virtual functions. Recently, LVM has some dead virtual function elimination optional tower with LTO. It doesn't work in LTO. And GCC wants to have that kind of support too, but they finally realized it's impossible to support it. And I tried the new functionality with LVM. It cannot remove the binary bloat with Iostream either. The linker cannot remove Iostream because they don't provide emit IR for the LTO, I think. So it just doesn't work. So I think I can show you an example. I think I'm going to show some examples here. The Iostream. Okay, let's just show an Iostream. Let's make an experiment with Iostream. So first, we create a main function, and what we're trying to do is just use Iostream, and we statically compile it, because it tells us how much it actually uses. You cannot say I'm putting in a shell library, I don't pay for it. You still pay for it. It's 15, right? But what if we include Iostream? Now you can see our binary size immediately increased for 850 kilobytes. What about other tokens? Let's just try Linux cross token, for example. I think I do have Linux token, which is x86, Linux Gnu, G++. Okay, we don't static because static we also statically need to leave as the GDC. We just do this. We static leave GCC and static leave SDDC++. Cannot find Iostream. Okay, I think I did something wrong here. whatever. Let's just try another torch. I'm sorry, I think I installed something wrong here. Let's just try PC MS-DOS DJGDT. Okay, and we need to just directly use that torch. I compiled a bunch of torches. Okay, let's just try this. Try this G++. Okay, so if you use this embedded system, you cannot use static linking right now at all, right? So I cannot find Iostream. No such directory. Oh, damn. I know what's wrong here. I'm sorry. Okay. So, right, it's 816. What if we just remove Iostream header file? Okay, 15. So Iostream always increase your binary size for 800 kilobytes. On some platforms, like MS-DOS, I think it introduced fewer bloat compared to Linux, because I think it's because of the instruction size is different. You know, the 32-bit instructions is shorter than the 64-bit. But we can see the binary size is 6 on DOS, for example. The DOS program is 607, and if we just remove that, this is 68. So Iostream is extremely bloated, even on all platforms, basically. You cannot say I'm putting share libraries that don't pay for it, you know. I actually just checked the Intel LDD with Iostream, is that the entire with obj dump or even read else, for example, the entire symbols in the C+ standard libraries, the C+ runtime is Iostream. You know, if we can just get rid of Iostream, we actually can just get rid of entire shared linking with Iostream, which is perfect. So Iostream is bloated, and compiler does not remove dead virtual functions, even with LTO, even with all these flags, you don't remove it. You know? So Iostream is completely unacceptable for both security, because you add a bunch of virtual functions, you have this bloat here, and Iostream is the inheritance graph of Iostream, because using OO can promote other issues like copy attack, for example, or VPTR injection. We can talk about later. But in general, Iostream is very bloated. You have the binary bloat issues with Iostream, which is bad, right? This is ridiculous. You know, just include the header with bloat 800 kilobytes. That's ridiculous, you know. And it's a low quality wrapper of a Firestyle, you know. Internally, they just wraps STTIO. So what's the point of using Iostream anymore? You know, if just the implementation just wraps Firestyle, there's no point to use Iostream anymore. Despite in the old paper, even there shows that Iostream is directly implemented by POSIX 5 descriptors. Now all three mainstream C++ implementations just use Firestyle. You know, it's just adding more performance and binary bloat issues. So, and you have the exception safety issues with the Iostream manipulators, right? You have the boost Iostream guarding the exceptions. I think they even have the criticism to C++. So the Iostream global and manipulator is actually a part of reasons why they're saying. So the global state, you know, have this global state, and you have exceptions. You have the exception safety issues. You can even see the criticism of C++, and many, you know, these don't like C++ because C++ did a horrible job on Iostream. You know, Iostream is horrible. You know, Just Manipulator is a horrible mess, particularly with the handle is a horrible mess. I don't understand why people use it, but just ridiculous, The operator overloading abuse, Why do you use them for operator overloading, They just make thread safety or process safety impossible to implement, And have also have the horrible error messages for incorrect types, because you're using operator overloading, right? You don't know whether some other people were using this operator overloading for different things, There's no scope, there's nothing, and it just emits errors to the compiler. It just emits things to the compiler front end. The compiler front end is very hard to distinguish this overloading. And Google benchmark gives some compilation performance issues with the operator overloading here, right? And you have these to see out 1, 2, you have to put a bracket here just to output left shift, because it just making stuff very hard to understand. Of course, the C+20 still makes any mistakes. We can talk about in the future why C+20 ranges also suck for performance in the future too. But operator overloading is something we should avoid, I'm not saying you should avoid in all cases, but I think using it for I/O is just very bad, You shouldn't do this. Of course, it does not work in freestanding either, right? It cannot, because it's just a wrapper of stdio, and it requires heap allocation, it requires exceptions. So it doesn't work in freestanding environment. So if you have no operating system, you cannot use Iostream. You have a chicken egg problem with it. Of course, I have all the locale. Okay, locale is historically horrible, It's horrible for the non-English speaking countries too. For me, for example, I'm a Chinese. I can guarantee you, see, no one wants locale. Even in China, no one wants it. It's just horrible crap. Locale is crap because it constantly throws things off instead of helping us. The problem is it's mandatory. It's not optional. There are no locale agnostic methods in C++ at all. The C+17 calconf is designed with a lot of problems, just like we said before, right? The presentation we said before, it's just horrible. You have to have the implementation issues, The often implementing incorrectly. Last time I chose MSVCRT is completely unusable with the locale. And implementations also varies from different platforms. For example, the DECH is something that just works on universal CRT, but the glibc is DECH from .utf8. So you cannot make your code portable on different platforms. The encoding can be different, all this stuff can be different, and it makes the C+ functions very slow, extremely slow, like space. C-type is not a historical mistake. It doesn't deal with execution chart set very well either. GB 118.630 as an execution chart set, for example. It doesn't work with UTF-8 very well, Some countries, and for example, some countries were using multiple characters decimal points. With that locale, the C++ locale just don't support it. Does not support it. It's a historical mistake. The C+ locale is horrible. It blows, and it blows. This is the largest reason why your stream blows. It's because of locale. You also have these thread safety issues with it. Thread safety, because locale is a global state. Global state, you always have global states with thread safety issues, which means basically all the functions in C++ and library is not thread safe. They are not thread safe, because locale can screw your things up. It's ridiculous, completely ridiculous. It's just ridiculous situation. And even these implementations, they just don't follow the ISO standard, WD10 standard. I think I even have the standard document we can show here. They actually, the standard is complaining that they don't support the standard, because right, technical support that it's not correctly supported. There's no LC accelerator, for example. There's no LC keyboard. There's no time zone keyword with LC time, and there's no, because for locale they should support time zone, for example, but there's no LC time with it. and the entire stuff is ridiculous. It's just ridiculously bad. They don't follow standard, and even so, they still implement it very badly. They implement very horribly slow. Of course, these are other problems with Iostream, is that Iostream does not expose its Firestar. Despite all these mainstream C+ standard library implementations use Firestar to implement Iostream, there's no portable way to export it, no portable method to construct with, for example, you have a Firestar, you want to construct a file buff. It's impossible, right? You cannot get file descriptors or Firestar from the file buff either. And those issues have been making talking with operating system APIs extremely difficult on all platforms, not just Unix-like platforms, but Windows as well. It leads to other problems like TOC, TOU. It's just because there's no way to talk with operating system APIs, right? There's a proposal which is native handle from Iostream proposal, just does not deal with the fact that different system might use different levels of APIs. And even using Firestar in Iostream might sometimes be useful, right? Because some APIs might just use Firestar. But that proposal only expose file descriptors with GCC, and this thing is GCC. I doubt he does not know even GCC can be used on Windows. Well, these people are stupid, These people are just making horrible proposals, and just a bunch of idiots, WG21 idiots, are just accepting these proposals. W21 just a bunch of idiots, just a bunch of idiots, in my opinion, Iostream does not work very well with C+17 file system, So, like I said, TOC, TOU, this is basically the TOC, TOU issues I mentioned before. This is basically a horrible mess. Of course, it lacks of UTF-8 support. There's no U8 F string, right? There's no U8 U16 for you have U8 string, but you have no U8 F string. It just tells you it's just horribly bad with it. The Iostream even lacks the basic functionality as a Firestar, for example. C11 and C+17 X flag, just for Firestar, for example. This open flag for fopen, for example. Just no Iostream EXL flag to match the EXL semantic or file POSIX. So this flag is doing it will making open functions fail if that file exists. That's to prevent TOC, TOU issues. But C++ Iostream is that flag. Even Firestar provides that flag, but Iostream does not. Iostream does not. Even it just implements with Firestar, it lacks the functionality with Firestar, which is ridiculous, just ridiculous. C++, and we can see it from the previous slide. Just basically, Iostream is fails, right? And people just creating these new dialects, and create these composition traps, just like the exceptions are facing right now. So that's why we need a fast IO library, right? Because the current solutions, they just don't work. None of them works. I've heard all these proposals. I just read all these proposals. I know they don't work, right? And we will continue to suffer from these bad proposals if they get accepted. And I hope that if WG21 can watch my video, I think they won't, because they think I'm a troll, except they are wrong, Whatever. Please don't add it. Please don't add these functionalities to C++. You are destroying the language. You guys are destroying the language. Okay. So the design, my fast IO design goal is that first, it designs around concepts. It doesn't use object-oriented feature. I think there's just one or two virtual in FastIO. It's actually not because FastIO itself needs virtual. It's because it's for type ratio functionalities. We can see there are more virtual is the virtual API import rather than virtual, And this functionality just removed. Basically, the only thing we use here is IO file. It's to it's type ratio. It's not even object-oriented programming. You cannot treat this as traditional object-oriented programming because it doesn't use object. It's implemented by this stuff, but it's actually type ratio. So it's not object-oriented programming. There's no object-oriented programming in FastIO. The different components of FastIO are agnostic with each other. Just like C+ containers and algorithms, right? They are agnostic with each other. The algorithm does not understand how the containers is implemented, and containers do not understand how algorithms is implemented. They just provided a general interface to make them efficient. That's some I want to learn from C+ containers and algorithms when I learn C++. The idea is that why we cannot apply the idea of C++ containers to Iostream, to some new I/O facilities. That is actually my initial idea of how to design new things, how I can design the things. I have an initial idea back in, I think, 2014, but I actually did that after 2019. There's some initial attempt in 2016, but in that period, just no compiler just correctly supported, just test the compiler basically. But now we have the functionalities, we can gradually achieve this. So I also want to integrate all these existing I/O related functionality to a single library, just making file system, networking, synchronized, asynchronous I/O, formatting, code CVT, process sound to a single I/O library. Because from operating system perspective, Unix has the philosophy, everything is a file, right? If your high-level abstraction does not match that POSIX semantics, you will suffer from it, right? Because POSIX designed that way. POSIX is the operating system standard. I know that a lot of people people despise these POSIX, but POSIX is POSIX. I think some phenomenon happens in Rust too. Rust also despises POSIX. I don't understand why they despise it. The POSIX standard did something very bad, but that doesn't mean C++ is doing better, So I think it's ridiculous. Exception handling is the only error reporting mechanism. This contract violation, like out of bounds, right? Yes, whatever, they will just crash. There's no reason to deal with contract violation. Or you allocate a very large, you provide a very large stuff. You want to allocate. It should also crash because contract violation. And it's 100% compatible with existing STDIO and Iostream facility, allow a smooth transition to the new FastIO mechanism. So this is basically the overall goals with it. There's another goals. It must be usable in freestanding environment. So which means even we don't have operating system, the IO library must work. This FastIO IO library must work. Not this is strict freestanding. It's not just still require libc like newlib did. No. This will work. This already works without libc, just with the freestanding torch of GCC. I've tested. Yes, it works without any libc, without any non-freestanding header files. It also supports all the existing legacy systems like Microsoft DOS, Windows 95, Microsoft Chicago, for example. Microsoft Chicago. You can watch that video about Microsoft Chicago. Of course, Windows XP, Windows 2K will also get supported too, but we want to support as many as possible. Probably Windows 1.2, 1.23, we should also support it. As you know, Windows XP and Windows 2K are already supported, no problems. I think the Neptune vessel should also get supported. Even long haul is supported. DOS is of course supported. There are still some platforms are running DOS. The reason is that DOS is running on real mode, it's not running on protected mode, and you might not do something which is only be possible under the real mode. It's locale agnostic by default. It uses concepts to make locale support opt-in in a non-intrusive way. So it's not like Iostream STDIO, everything is locale by default. It is optional locale, it's not guaranteed locale. You don't have the locale by the support. It's locale agnostic. You don't have the local. You don't need to afraid of locale. And we will also provide locale, locale agnostic related functions like is C space, for example, which is like E space, but it's locale agnostic. Rewrite entire locale. Okay, so we rewrite the entire locale based on GDC's data. It's public domain, right? You don't need to worry about licensing issues, and also avoids data. Avoids data. And this data avoids C and C++ functionalities. They're done by using DLLs. Basically, what we are doing is loading them as DLLs as database, so we can load the data. So it works for all character types and episodic execution process. So IBM cannot cry about this situation because the library will perform things differently if you're running on episodic execution process. It works correctly on the episodic execution process. So we also need to rewrite other broken features like chrono, like file system, right? So using the POSIX standard as a new guideline to design new APIs. We also need to provide a new simple cryptography to ensure at least we can connect the internet, right? I think that's minimum. We must provide some simple cryptography functionalities. You cannot rely on operating system functionalities. I fail to see why that of cryptography relies on the operating system. There's no reason cryptography relies on operating system. There's no format string, there's no format string problem. So we don't have format string, we don't have format string vulnerabilities. You might say, what if I need locale based? Well, this actually is some kind of format string for support, but it's not. It's very restricted. It doesn't support a lot of stuff, and it never fails. When you had a format string errors, it just output formatters. But we're not encouraging you to use it, unless you are knowing what you're doing. And when you're using it, you should not. I think you won't worry about the issues with it. Also, it avoids the confusing overloading, like Chakon style. Just something I really, really hate. The problem is that this libc implementation is usually using the int8 t with the aliasing with the char. You treat it as an integer pointer, but if like these Iostream or even FMD doing is that they will get outputted as the string. You want to output them as pointer, but they're string. That just crash directly leads to a crash. Just your program just randomly crash because of the confusing overloading here. So it is always a pointer. Like Chuck said, we always output as the pointer value. It's not a string. If you want a string, use a manipulator. So we don't have the C+ nonsense as C unique part as the harmful span. They are in-cache harmful code. Unique part is very, very horrible. Unique part is harmful, considered harmful. Span is not a very harmful stuff because it works. It has ABI issues on MSVC ABIs because its bias is 16, and my MSVC it will not pass it by registers. It passes by value. That's ridiculous. The span is very bad. So let's just see an example of hello world, facile hello world before we can talk about things later. So we have a print hello world and just print hello world. So it's not a format string, okay? This is not a formatter, just format string. It's not a format string. It just prints things out. It writes the hacked file style std, which means, okay, I think I can show you a summary, how that works. So we need to compile it, right? We need to compile with GCC. Then we okay. Right. I think we okay, we can see program runs. What if we put a % here or what kind of stuff here? It ignores these things. There's no such thing, you know. Are we doing the right thing? Oh, I think I did not save my file. I think it's the reason. Or it shouldn't behave right. There's no format errors. There's no format string at all. So it's not a format string. It's just printing things one by one. For example, we print something like 400, and we can print it whatever we want. Okay. It does not separate. If you want to separate things, you need to manually put it here. You cannot print a character, you know. You cannot put a character. Please just print a string. You cannot do this. It prints the value of that character. It's a character. It's not a string. So what we always need to do is using this. Because it's confusing. The reason is that some people would, in the AT might be a character. We'll see whether it was implemented. And you can see this sign char. So the problem is it might be a char, which is why I don't use it. Because in some implementations, if they're using char, then you get a crash because of that. You have no way to ensure a portable behavior with it. So you just print things one by one, and that's how things work. So we want to see what the assembly generates, right? What does the hack stdio means? We can use fhook program because fhook program can show us the correct assembly without using LTO. So it's still using exceptions, you know. Sometimes using exceptions is very hard to read code. You can just disable exceptions, RTI disable. Exceptions, one problem with exceptions is it makes the code write very, very hard. Because I re-implement with entire stuff with stdio on Windows. You can see it directly calls write function. Even if it is write to fire star, it writes to fires. You don't see any fire stars functionalities here, right? We can see here is just all the implementations are implemented by fast.io. So that's how the assembly is generated. Let's see what's the binary side. Okay, we can also use the static. What's the binary side now? It's 29. So if we disable exceptions, and what's going to happen? Because fast.io is now using the current exceptions, it's only 16. So when we disable exceptions, we will not have any bloat here. And we see what's the binary bloat with Iostream before. Do you remember that? Right. Native. Oh no. Iostream. I think we did not include anything, right? We need to print a hello world, for example. And even we don't print hello world, we just include a header file. It blows binary side. You can see it's 515. So you can see the binary size is already reduced compared to, even with exception handling. We only introduced the exception handler with GCC. Of course, that's something I don't like, you know. We can just static lib GCC for lib stdc plus one in the lib GCC. Oh, it has 3 kilobytes of bloat. But in general, it's the reason bloat is not because of my libraries. It's because of the C++ exception runtimes. It's exactly another reason why I hate exceptions. It's because exceptions blows my binary for no reason. It might not be a problem for you, but it's a huge deal for me because my binary size increased for 100% because of the Iostream. Because of the exceptions. So the Iostream, you might say, what about if we disable exceptions with Iostream, what's going to happen? It doesn't reduce anything, nothing will change. So, because internally it still use exceptions. So it's right to hack a file style. Then what about the second example? I want to show. Yeah, so it's just write to stdio. It's synchronized with stdio, so you can just use with stdio. Some people say, I don't want to use stdio because I'm in a situation I don't have stdio, for example. Or I do have stdio, but stdio will add a lot other blows with it. I think one example. So we can just directly write to native out. You can also see them on these examples. We can just try. I think we can try those on with Windows and Linux. I have a Linux course portion installed. Okay, I first show my GCC compiler, GCC version, which is GCC 12. So RTO static. First we run the program. Yeah, it's 28 because of exceptions. We can disable exceptions. We don't have the bloat anymore. The binding space is 1 kilobyte smaller than the original one because here it doesn't rewrite the STIO, just to do the things it needs to do. So let's see a sample. Probably say, okay, the exceptions. Let's just disable exceptions. We can even do something more, not just disable exceptions, we disable more things. No identity, no asynchronous exceptions, no on one table. Asynchronous. I have no asynchronous exceptions. I have no synchronous on one table. It should be I have no on one table. I have only synchronous on not I have no asynchronous exceptions unsynchronous on one table. Okay, here's a summary generate, right? It is just as bad, as good as you write a summary, right? It just write file down, nothing else, It has a code here just crashing here because we deal with the exceptions, deal with the incorrect error code, we just crash, and we're done. So, what about Linux? Let's just try Linux, okay? So we try x86. Linux, Ubuntu Linux, Linux GNU. Okay, what's the assembly we have? See, it directly invokes syscalls, right? It's just exactly the same as the assembly program would write, right? There's some headers, there's sections, but in general it's the same, right? It's just the same as assembly. There's something our compiler is doing, the compiler GNU stack. But in general, you can see it does what exactly the program is doing, like assembly program would do. So the code is great, just great. So of course you might say, what if I'm writing more things here? What's going to happen? So it actually calls write B. Okay. You see, the opposite things just get optimized by compiler. It's multiple writes. I think we should just try Linux, for example. x86 Linux. I always disable exceptions because exceptions deeply affect how I can read code. there's only one syscall. It's not two syscall, it's just one syscall and no heap allocation. You might say, how does that happen? What it actually does is using the write-v syscall mechanism to do that. So this is this syscall called write-v, and it can do that. It can do that. When it just directly invokes syscall instruction, there's no libc call. There's no write-v function. It is a syscall. It then compares the return value and done. So it's just as good as writing assembly by yourself. And I'm just fascinated by these C+ container-related concepts. People usually call this stuff as STL, but STL is not official names. There's no STL actually. So there are 4 parts, right? The allocators, containers, iterators, and algorithms. So FastIO is designed around the iterators model, which is you can define the IO library with different iterator types. You don't actually guarantee it must be a contiguous iterator, because you might have some kind of IO device which is not contiguous. It does not use contiguous memory. We have to think about this data structure. They might have a usage we don't know. They might have their very good usages we might find in the future. But so FastIO also provides its own 4 concepts too. So they are designed with iterators first, okay? So IO buffer can allow different implementations with it. So there are 4 parts, and they are agnostic with each other. There's no strong relationship with each other. For example, we have custom IO type device. We have custom types. Even integer printing string are all custom types. Okay, there are custom types and there are concepts to deal with these custom types. And FastIO concepts know these concepts. It doesn't understand these types. It only understands the concepts. It only deals with concepts. Okay. So we have custom IO device, custom types, which is you can define whatever types you're doing. We have static IO manipulator and decorator. So we have 4 parts: device, types, manipulators, and decorators. I think the first 3 parts people will always understand that, but this 4th part, decorator, is something I need to explain here. So the difference between the custom IO device with FastIO with other IO library implementation is that there's no inheritance. You only need to satisfy concepts. And we don't use a method. Okay, there's no method using it here, because they are inefficient due to the actual this pointer from API perspective. Because when you define method, the compiler will inject a this pointer. The this pointer is extremely inefficient. Okay, from API perspective. We're also exposing internal implementation like mutex or IO buffer pointers here. So you need to expose IO buffer pointers to gain performance. Okay, or mutex. We have an interface you must expose them to make it work correctly. It also deals with thread safety and process safety correctly. Because when you provide mutex, for example, I can do things what you cannot do. Or process safety, if you're writing a native file, for example, when you have write-v, just like the example showed here, the write-v itself is somewhat a process safety for some device from kernel perspective. So we can just exploit that process safety functionalities from the operating system kernel to get things what we want, just directly with process safety. And it probably can ensure you flush the buffer, for example, if you really care about that kind of stuff. So it ensures the process, you deal with thread safety and process safety correctly. So the first, of course, we talk about types. This is just a brief explanation. We cannot just explain everything in this slide, because each of these topics can just talk about now. We don't have time to talk about that in this general design of FastIO. It is off topic. So the custom types is just first allows like C+ or Iostream. Like it's not C++. I think just do something wrong. Can I just modify it? Why can I do this? Okay. style or not style, but it's not done by operator overloading. It's done by using this print define function, and it returns void. It doesn't like Iostream need to return the string type itself. Here you don't. You only returns void. Okay. So it is, even from ABI perspective, it's more efficient. But I prefer you to use print reserve define. The reason is that it's IO agnostic. This function just directly replaces clearconf, and they work for different characters with iterators instead of just pointers. It works better than clearconf. It also avoids more efficient implementations and saving more binary size, because it doesn't check bounds. It's just no bounds or copying here. Even you were using clearconf, then you're doing IO, you need to copy that buffer, which is very problematic for performance. This also allows more aggressive optimizations for scan, transmit, print, or copy later. So we have row print function of the scan function and transmit function. So they do not need extra bound checking or copying here. They allow merging binary for different IO device with pointer. I was worried about whether I'm just actually recording here. Oh, I did. I hope I don't make a mess here. Just don't copy that stuff. Just that would be very bad, right? So it's not recording, just wasting my time here. It also allows these different IO devices just merge the binary. Just all these IO devices would only use one function. Just one single function. It always ensure you only use one copy inside your binary instead of multiple kind of pointer of copies in your binary. Because C++ template, even the functionality is the same, they will duplicate. We can talk about these problems in the future, later. Compiler is very bad at optimizations. So they don't even need bound checking. We allow merging binary at binary level. They allow more aggressive optimizations. So if you can use print reserve define, don't use print define. Okay. We can talk about how to define that in the future, but it's not a topic here. We're talking today. So static manipulator. Static manipulator the problem with C++ Iostream manipulator is it's not stateless. It's not static, right? So fast IO's manipulator is static. The manipulator just grabs the object or reference of the object. It depends the size and ABI of the object invoked functions. For example, print fix 0.006. So it will print the value in fixed format, or it's proposed as general format. So the manipulator can compose it with each other. For example, you can put a fixed here, then you put a right here. So you can, then we do the things. Probably we can just show you here. We just print this stuff. I hope it just works. Just frequently, because implementation is changed. Keep changing it, and it doesn't work anymore. I hope we're lucky. We're just working today. It should work. I don't want to change my example because it screwed my examples. We just create another called floating, for example. Fixed. Fixed. We just put that example. First, we need to. Oh, sorry. First, we need to using namespace. And we print. We print this. Print this. Okay. Floating. It should work. It just doesn't work. Why? Copy backward. I understand. It's just older versions of it. Old versions of it. Versioning issues. Yeah, it's not that. You see, here we have a wise here. You can also define middle wise. we can have scientific. Okay, so we can scientific wise. So you can always output that as scientific format. Of course, by default, it outputs as general format. So comma. We can also output this as comma general. I think it's comma general if I remember that correctly. Sometimes even my own self cannot remember all the manipulation. Yeah. So sequence. What's happening here? Okay, 3 comma 4. Because by default it outputs as dot, right? We usually write dot, but in European countries they are using comma. So by using this comma, it allows you to print and scan formatting the floating points with comma. So manipulator can not only be used for input and output type, but for I/O device as well. For example, we can imbue a locale. I think this is probably not. I think I shouldn't show this today because we're going to show a lot of stuff and people will not listen to it anymore. But in general, understand the manipulator not only for work for types, but for devices like locale, for example. This is taken by our manipulator. They don't understand each other and just they don't necessarily mean you always need I/O device to use manipulator either. I think they just operate types. No, you don't need it. Decorator. So decorator is something we haven't heard before, but something we know that because of the standard code CVT, this is something working Iostream. So decorators are some operations that apply to I/O buffer, like code CVT, like compression or encryption. A decorator maybe is not a good name because I just call it decorator. Maybe you have some better name, you can tell me. But in general, it just works directly with bytes on the I/O buffer. It just can do code CVT, compression, encryption, for example. It works from differently from OpenSSL filter because this directly works at the I/O buffer level instead of the I/O device level. So the decorator is also agnostic. So you can use that for creating your new other abstractions, just like I/O manipulators. FastIO provides its own code CVT mechanism, which means mechanism is not mechanicism. Mechanism. So with similar instruction. So that means it's extremely fast. Just even invoke overflow and non-flow I/O operations. If you don't know what is I/O overflow and on-flow I/O operations, I suggest you to read the CPU reference about the basic ideas of Iostream. I think a lot of people just don't have no idea of the basic the buffer manipulation operations with Iostream because they hate it, But I think there are many good things we need to understand about Iostream. So overflow and underflow, these buffer pointers is actually a very good design with Iostream. They did it very well, including the tie. Tie is also very good semantics. It also avoids a lot of potential memory allocation failure because I've seen a lot of people just doing code CVT. They're just reading entire string file into the file into the memory, and then write it. It's not efficient because you have cache locality, you have extra allocation, you also have the memory allocation failures here. So it's very bad, so the ways will avoid a lot of potential memory allocation failures. Okay, the I/O operations. Okay, so what's the operations the service FastIO provides? It only provides some basic I/O operations. I think just basic operations because they also provide a lot of other functionalities. Basic I/O operations. So it only provides print, scan, and transmit. The behaviors can be changed with status concepts. That's how FastIO implement locale. Is that if you satisfy another concepts with a certain type, then print scan will perform things differently. That's you implement locale. Transmit is transmitting data framing data from I/O device, from input device to output device. It usually can be used for copying, right? We can say transmit data from one copy for another copying. But in fact, it can work for encryption or decryption, compression, even calculate crypto hash like SHA-256, SHA-512, because if we abstract them as I/O device, or even BlakeSpring, even because if we abstract them I/O device, they can be used for transmitting. They are highly optimized, and it works for these crypto device. They need, for example, they need to secure clear their buffer, for example. They need to erase data in the data. They don't want leak information in the side channels. The crypto hash, it can work for crypto hash device. They are highly optimized, and they might even invoke NR syscall, send file syscall to promote a zero copy transmit. So this transmit might just invoking the operating system kernel instead of doing in the user space. Remember the second manipulator I've said before? Setting manipulator can actually do async transmit, right? Can control how you transmit things with async. You know what I already think, I actually do implementation with async print, but I think async print is not efficient enough, and when you want async print, your implementation is very wrong. So please just use async transmit to a buffer, then pass it with string Iostream view, which is basically string in fast I/O specific, but it's only string view. You don't need copy the string. What if we want to load the entire file, right? I've seen a lot of people loading a file. They just seek. This is very bad because you have allocation failure with seek, right? So there's actually a native file loader type. Okay, it's an AES violin implementation. It's implemented by file memory mapping. It's a contiguous range, and we can directly avoid standard algorithm with it. Users can swap to other file types of underlying implementations that provide them. For example, on Windows we have multiple implementations. We have particularly SIGWin, I think, just provide lots of implementation. So they will all get implemented. They are supported. If you think this implementation is not appropriate, you can use another implementation. And our allocation file load is always provided because some systems like Microsoft DOS or WebSM, they don't provide memory mapping. So on those kind of systems, you use malloc to allocate memory. It doesn't use operator, you use malloc because it tries to emulate the behavior of these POSIX APIs. So it uses malloc. The data is loaded as private page. So if you try to modify the page, the operating system will copy on write to give you another page, and it doesn't affect the existing file of the content of the existing file. Okay, you might say, what if I just want to affect the existing file? FastIO actually provides memory mapping for them, so you can just use memory mapping. Okay, if you really want that, you can just use memory mapping. But I think usually people just want to load the entire file, so we can do it very efficiently. And they can avoid the issues with allocation failure for loading this large file. Probably more efficient because you only load page, you don't actually read them, you don't actually copy. So loading entire file, we can just use the native file loader to do that. This part is, I think a lot of people will not agree on it. They don't want to see STIO and Iostream get supported, but I think it's impossible because we have existing billions of lines of code of STDIO and Iostream code base. Despite Iostream is largely banned, many projects they don't have resources to buy Iostream. This is actually the Dragonbox, thanks to J.K. John. The Dragonbox algorithm is also for porting that. So this will also improve the performance of existing STDIO, Iostream, and STDIO facilities. Okay, I'm doing things wrong here. It also allows talking with operating system APIs in a general form. and it also will avoid its implementation detail issues because they're implemented in a general form instead of a platform-specific form. We're going to talk about that in the next slide, next few slides. So for example, we use Windows as an example. So FastIO provides 7 file types on Windows. We have NT file, ZW file, Win32 file, POSIX file, C file, C file unlocked, and the firebar file. They also provide their own this char680 version, char16T version, char32 version, wchar-T version, and yes, U32 firebar file and U32 ZW file does exist. I should do it, does or don't do it. Okay, whatever. And every file type has its own IO observer type, like NT IO observer, C IO observer. The reason is that you might have C interface, right? You might have existing APIs that just using Firestyle, and you just want to use Firestyle in part of your code with this CI observing part of your code. You don't actually want to use C-file because C-file is an RAI wrapper. It will close your file. You don't want the file to close. Then you can just use CIO observer to use that with FastIO functionalities. And every file type is inherited from their IO observer type to allowing passing them by value and avoiding binary overload. If you're passing them by reference, they will always be passed by reference, which is even if it's just an integer, it's not passed by register. So the IO observer also allows that things to be passed by value. Of course, you need to be very careful. If you're passing the IO observer by reference, you might have a double free with it. So be very careful. Please just pass them by value with IO observer instead pass them by reference. C+ community loves to passing things by reference, which is very bad. They don't understand the API. They don't understand things. They're just passing everything by references, which is terrible. And each type only have one data member. For example, for POSIX file descriptor, POSIX file only have file descriptor, FFD. You might say, why do we have file descriptor on Windows? Yes, Windows does provide file descriptor, okay? This is a common misunderstanding. A lot of people think Windows does not provide file descriptor, So, FastIO also provides native file. Native file is just Win32 file on Windows. Native file is Win32 IO observer on Windows. If you want CRLF support, you must use C file and C file unlocked with the open mode, with the text open mode. Okay, native file observer does not provide that. Although POSIX file provides that, but it doesn't guarantee your code will work on every platform. Because on Microsoft DOS, for example, the CRLF is actually implemented as Firestyle level. Probably in even old versions of Windows, it also did the same thing. So it's not a portable behavior. If you want portable behavior, you must use C file and C file unlocked instead. Also, it works for other operating systems. So I think we can just show here actually how Iostream works internally. We can see on Windows we have NT kernel, we have NT DLL kernel system. It's not CRT, it's MSV CRT or UCRT. So we have read-write, and we have Firestyle, we have Firebuff. So we have 6 layers. You might say, what's the ZW file is doing here? Windows actually provide 2 sets of API, which is NT APIs and ZW API. NT APIs will only invoke NT APIs, and ZW APIs only into a ZW set of APIs. They are same on user space, but they are not the same in kernel space. So if you're using FastIO to write in kernel, operating kernel drivers, you might need them. You might use ZW file and NT file. You might need to deal with the difference between them. So native file is Win32 file. And you must use C file if you want text plus open mode, okay? Text open mode.text. FastIO.open mode.text. Okay, open mode. So this works both for MSV CRT and UCRT. It works for all the combinations of C++ library and C libc. It works for MSV CSTR, GNU libc C++, and LVM libc. It also works for Windows-like systems like React OS or Wine if you're on Linux. If you're using Windows-like operating system like React OS, it also works. These types exist on Cygwin too, but they work a little bit different because Cygwin just completely, they do something very different. You cannot just using handle to construct file descriptor. You probably can, but you cannot just do the reversing. Cygwin will do some guessing, so you cannot just construct them with each other. So types, though this type exists on Cygwin, they work a little bit different in general. So Cygwin is a very different environment compared to your MSVCRT or UCRT environment. The FastIO provides hacking to MSVCRT and UCRT file stuff. So actually that's why we are seeing in the previous, I'm just showing the demo here, just why you don't have actually have right here. It's just because FastIO just completely rewriting higher MSVCRT and UCRT because Microsoft did not implement buffering correctly. There's no line buffering with file stuff. What I did is adding type to std and std out with it. So you can see std and std out get synchronized because they have type semantics. So we can, I think I haven't shown that one in the examples I want to show here. The example is actually, what about let's just one single just example with file loader. So we can just load the entire file, can print it. We can do the things whatever we want. It's a continuous range. But here, what we're gonna show is the legacy implementation. So we want to construct a C++ Iostream with NT file. Right? Windows, we have NT syscalls. We want to move them. We want to just move them, then just C file. We don't actually need to, we cannot construct from Win32 file because they are still in the same handle. It's just our observer. We don't actually need move them. We don't actually need to move to Win32 file. We're just directly using NT file to construct POSIX file. Then we use POSIX file to construct C file, and we construct C file to construct filebar file. Right? We have file start. We use file start to construct an Iostream. Then we use that with to move. We get a POSIX file buffer, and we can use the timestamp or just this output some time. We can show. I will tell you what's the time later. But here we can just output all the things we need. We can see that if it's file buffer IO observer, we can static cast from the lower level to higher level to lower level with static cast. From lower level to high level, we do a stu move. Okay, stu move, it is basically, you can just directly stu move from NT file to file. I just want to show you how can you do that one step by step. You just directly move stu file to a filebar file. After we use that, we can just move that to a stu rebuff. It's because it's a stu filebar. Then we can just use filebar resolver with it because we already moved that. We cannot use the FBF. Okay, can continue to use that. Or it's just, if you use that, you get a Manipulator crash. You get a crash. Probably not get a crash. Probably not get a crash because they don't even, it just become a default initialized F-stream after that, but it's not necessary to crash. If we with crash, probably could crash. No, we don't care about it. So after crashing, please don't use it. Just move that to through via F-stream. Then we have F-stream. So we can use this. You can see we're just using all the implementations. You might say, can this code actually work with GCC? So we can use that. We can try that with GCC. Okay. The reason we need is that we need to link LDA NTDIR because it's using NT syscall. We must link to NTDIR. So this code gives us all the information we need. It gives us Unix timestamp. It gives us UTC time. It gives us our current time zone. We can see it's exactly the same as the local time, right? Because UTC time is also the same. And it gives us a very high precision, right? It's very high precision compared to standard library. Here we create even more precision. I think 7 digits, 6 digits, because the happens is just 0 here. then it prints out FP file descriptor. We can see, yes, Windows does provide file descriptors, right? Here we have a file descriptor, which is POSIX IO observer. Then we have NT handle. NT handle is different each time you run the program. Win32, ZW, and NT, they are all the same. Okay, so Win32, ZW, and NT handle are exactly the same volume. But if you're using Win32 IO observer, ZW IO observer, NT IO observer, you can static cast with each other. And when you call in with Win32 IO observer, it invokes Win32 APIs. When you call ZW IO observer, it invokes ZW APIs. When you call NT IO observer, it invokes NT APIs. So these APIs are invoked differently. You can see this actually works with libc to C++. Now you might say, what if we run with clan, for example? And if you use clan, we cannot use, we need to use RLD as our linker. We can just try what clan is doing. Yeah. See, it gives us the correct answer for clan 2. Grab the same answer. And we can use this stdlib equals lib C++, right? Lib C++ is LVM's implementation. And we need to link sub C++. I hope the code can work, but sometimes it doesn't. It just doesn't do the right thing. But we need to probably link to libstc.drl. Okay. You can see we can show his LVM libc++, right? It's not just GC could work. It also works with LVM torsion. I think, if we are lucky enough, we probably can do. I think this is probably not going to work, because if we just try to use GCC reversely, it will show a linking error, I think. Yeah, it has a linking error, because this actually something doesn't work correctly with the libc++. I just cannot find the typing for here. Can we just disable the typing for here? I have no RTTI when it works. Okay, it works. So you can have GCC with libc++, and it works correctly on Windows. This is on Windows. It's not on Linux. On Linux, if you're on Linux, these 3 lines of code will not get inputted. So, but other features should be exactly the same. So we have tested. We are using both GCC and LVM with different combinations, and they work exactly the same because I hacked every C++ standard library implementation. libc. Let's talk about continuing libc. So FastIO provides hacks for all the existing C library implementation. Because the reason is that supporting std in and std is tricky. And if you're re-implementing IO buffer, it has pointers binary bloat and incompatibility with existing Iostream facilities. That's why I use sync with stdio, and it works extremely slow. And we also welcome this OS vendor just contribute code to provide you hack to your own operating system. Some platforms like PicoLibc is a little bit tricky because they don't actually have any buffer. On that kind of platforms, CIO observer is not a buffer opera stream. It's not inherent from it. It does not satisfy the concepts on this libc implementation, because we cannot control how this libc is implemented. These are existing platforms we support. glibc, MSVCRT, UC Universal CRT, Wines MSVCRT, Wines emulated MCRT, React OS MSVCRT, React OS emulated VCRT, BSD libc, the FreeBSD, OpenBSD, Dragonfly, etc., and our Apple Darwin. Master libc, DJGPP. DJGPP is the libc for Microsoft DOS. Okay. Newlib is frequently using these embedded device or bare metal systems, so Newlib is also supported with hacking. Although the PicoLibc is also Newlib, but it's actually we should just call it PicoLibc. Bionic is also supported. UClibc is also supported. WSI is libc is also supplemented, and this is my mlibc. Okay, mlibc. So since it's a new libc, it still contains a lot of bugs. You can try to see the mlibc is not just working very well at its current point, because it's still, I think they are not fully implemented. There's a lot of bugs with it. It will get improved with time in the future, we can see. So these are existing. We have hacked the implementation with it. Probably to do this, we have in the future libcs. But in general, FastIO provide hacks to a lot of libcs, right? Particularly on mainstream platforms, glibc, MSVCRT, even DOS we provided. So it should not be a problem for existing libc. Even you are running on libcs which are not on these platforms, FastIO provide emulation layers that can correctly deal with it. So you should not worry about too much about it. And also, because I hacked it on this platform, they will work very efficiently. Because they're using FastIO's algorithms, they merge with FastIO other types. It's actually using FastIO's functionalities to manipulate them. Okay, it's not a normal, it's just hacking for every platform. So it's working very differently. Even Android will provide that. What about Linux? So Linux FastIO provides 4 types of Linux. So of course you don't have Win32 file, ZW file, whatever. What we have is just POSIX file, C file unlocked, firebar file. Firebar POSIX file will directly invoke syscalls with inline assembly. The implementation is the syscall I just showed that is actually reference from LVM compiler runtime. This is a lot of FastIO works without the libc and avoid error null, which requires thread local storage. But some stuff we cannot implement that, like clock at time, right? Clock at time we can implement that, but if we don't use VDSO, it's not efficient. So with clock at time, we still need VDSO. VDSO to support game performance because it's faster than syscall instruction. And Natify is POSIX file on Windows, Linux. So remember, Natify is Win32 file on Windows, and Natifier is POSIX file on basically every other platforms. So what about, you might say, I've seen iBar file, low-bar file, what are these types doing? These types is actually defined as basic iBar file, but it's a little bit different is that they also need to add a basic wrapper just to add open mode. But in general, just add a buffer to Natify. So on Windows, it's basically native iBar file, iBar Win32 file, right? On Linux, it's basically iBar POSIX file. They provide WCHT, WCHT, Trust16T, Trust32T versions. uBar file, as example, and we also add, if you have a mutex as suffix, you add mutex. For example, iBar file mutex, it provides thread safety. So if you want to thread safe iBar file, then you can use iBar file mutex, and it will synchronize on all the platforms, on all the systems. Yeah, yeah. So that's how it is implemented. Wait, I see. Some people say I use 32 UTF-8 file. What does that mean? This actually the decorate how the actual decorator works. See the FastIO device definition because it's too long. This means the internal coding, which is what you processing the coding is UTF-32 native ending, which is depending on ending nodes, and the external file encoding is UTF-8. So it's just basically the normal case we deal with is UT encoding from the character point, right? Also, FastIO provides GB10, which is used in China, and UBCDIC, which is deal with IBM's platforms. If you're having an IBM virus, you need to use UBCDIC. So it converts to execution chassis. It's not local chassis. It's converted to execution chassis. Okay. So iBar file, which is not usage to iBar file, which is iBar file, is converted to execution chassis. So you don't actually need locale. It's nonsense. It's used. No, that's like a nonsense. This time we need to rewrite it, right? Because C+ kernel will by overflow after Wikipedia said you will overflow after year after 1600 years ago, we have overflow, and the year will also overflow after 82, which is after 30,000 years later, you get overflow. We also need to match the exact semantic and POSIX. So POSIX clock get time, or POSIX clock set time, for example, it matches exactly the semantics as POSIX. Okay, I'm worried about it. I'm super worried about it. Just stop, because the video is too long. I think it's probably need 2 hours, probably even 3 hours, just to explain everything. Because it is too long. It is a very large topic. On Windows, you might say how the POSIX clock get time is implemented on Windows. We can just use that Win32 APIs. We can implement it. Time zone. With time zone, we just reuse this existing libc time zone POSIX TZ side APIs to avoid binary bloat. It's not parsing that stuff, not like this to Chrono is doing. This is useless, that kind of stuff. You usually don't need to parse the TZ database. It's just not something you want to do. And it's not portable. Some platform is cannot access in file, whatever. Or it's just basically a mess. Basic timestamp is like struct timestamp, right? Except it provides a higher and flexible precision for sub-seconds. So it's like struct timestamp, but it provides sub-seconds, and that's why you have the Unix timestamp. I think that's why exactly I want to show here. It's still this example. I can first show some simple examples. Just show time. We have a POSIX TZ set. We can just using clock get time to get our real time. We can then using the local Unix timestamp, and what you call UTC, it constructs the ISO 8601 timestamp. It allows an efficient text exchanging with ISO 6001. So it allows an efficient text exchanging, and we can use it. ISO 601. File system. Okay, file system, like I said, it has the TOC, TOU problems. We also want to match exactly the same as POSIX relative APIs, like POSIX unlinked. Okay, the API works for all character size type, because POSIX only works for char, right? So here it works for all character types, including UTF-32, UTF-8. On Windows, they are implemented with NT syscalls. We don't use pass. This is no pass. This is two file system pass nonsense. We know pass. Pass, you have thread safety issues. Okay, there's no stu file system pass. It's nonsense. It blows your binary size. We don't want that. On Windows, they are implemented with NT syscalls. NT syscalls. NT APIs. NT syscalls and NT is usually the same, but on this context, I should just say NT APIs, not NT syscalls, because they are not actually syscalls, because Windows is basically using the NTDLLs like syscalls loader, because you have different versions with NTDLLs on different operating systems, and the syscall number is different, and you will get a whole mess. On other legacy operating systems like Microsoft DOS, they are implemented with absolute pass, because on Microsoft DOS is not multi-threading. It's not a problem. It's neither multi-processing and multi-threading, so it's not a problem with DOS. So diafire is actually how we did that. But usually just add a mobile mode, a directory over mode to native file. So file above file can be a directory handle, So we can making of Fstream become a directory file. And if, for example, we can using stu file after floating directory if you want. Yeah, that's basically how it does. For example, we have this code. We can just directory. We want to know how all the lines in the fast IO in this directory, for example, in this directory, and you can recursively loops the directory. So you need to provide add to tell the function you are treating that native file, because it's a native file, right? You need to treat that native file as a directory. So you can replace that with filebuff and open mode directory, and you can use it. Then you call extension. They use DRT. DRT just directly converting this entry to the DRT, to the native file loader. You don't actually need to rewrite twice. It's basically making the file loading, the open file, becoming much easier. Then we can just using string ranges to count all the n in the loader. Then we see the lines of all the C+ source files are, yeah. So it's very simple. We can just use that to count it. If you're going to count your source lines with code, you can just use this program. It's very efficient and very simple compared to, you don't actually need to concat path. There's no path concat. You're just using add, add is very simple. This is implemented by NT syscalls. Okay, this is directly implemented by NT syscall. It's not Win32, it's in NT. Okay. It also works for Unix too, but it's basically the case. So freestanding environment. I want the library to work without the operating system. So FastIO is actually usable without operating system and libc. It will do full freestanding environment, which means we only have this header file. It's not a fake freestanding environment like newlib. It does not need newlib. You can just using a bare metal complete for freestanding torsion to use FastIO. We try to make as many facilities work as possible, because some from facilities is tricky. But if you want a freestanding environment, you must provide IO device also needs to support scatter, right? If you want to divide a kernel terminal, I actually provided an example before how to do this. It's actually a FastIO driver. You can just use that instead of writing it by yourself. So if you're printing integers, printing floating points, printing hex pointers, string ISO6001 timestamp, they don't need stack. They don't need EH, they don't heap floating point decisions. But if you want a precision-based floating point, if you want to print floating points with precisions, then it requires operating. You need a heap, but it might be very tricky, because I think I've heard of the Windows kernel in some heaps are interrupt heap and interrupt unsafe. So basically, you should not print in floating points with precisions, but you can print them with stack, no problem. Bringing this target line, which is all the fancy stuff we need. So even in an environment that you have stack restriction, because all this stuff on a stack, you might have stack overflow problems. So be very careful. Yeah, I actually write a simple kernel with it. It works. So cryptography. This debates. Is it debates or diabetes? Just sometimes I hope I don't write the diabetes. It's debates. It's debates, no problem. There are debates on whether it should be or should be supported. The problem is that OpenSSL or cryptography library is actually an IO library. So I think an IO library has to be a cryptography library too, right? Because it has to be supporting some form if you want even basic TLS to work, right? If you rely on OpenSSL, it doesn't work the way you would like to work, and you still need to understand the logic behind it. You might save some implementation detail issues, but in general, it's just making things very trivial, or even very complex, very hard to deal with. You have all kinds of issues with it. So I think I think we need to design some symbol form with it. And it must work without libc. So there's some papers talking about this embedded device, it cannot work with it because they don't have provide libc. That's very problematic, and it has to provide functionalities writing C-party API cryptography libraries and OpenSSL BIO. It also allows FastIO itself to deal with crypto semantics correctly, like auto-secure clear on transmit, for example. You want to transmit some data, you want to just clean the buffer, and you don't want to leak information to side channels, and we have to implement something which works this way, right? Basically, you have to ensure entire call chain that don't have the problems. So that allows we can deal with that from a high level perspective. Public crypto. So my basic support is that public crypto RSA is not supported, but we only support advanced curve 25519 and the curve 2519. ED2559.9 is too slow, and it's too slow and bloat, right? And Rust nonsense. It's just Rust is nonsense. I just show that it's too bloat, it's just very bad, and it's slow too. So they must get implemented by assembly directly, since making instructions are only provided by compiler, not provided by, they are not provided by compiler intrinsics, and you cannot implement it efficiently without assembly. Symmetric crypto. Then what about symmetric crypto? We support AES-GCM and char of poly 1/3/05. Crypto hashi. Crypto hashi is MD5 and SHA-1 is deprecated, but SHA-200 is, I don't know whether these SHA-215.6 and SHA-200 will get deprecated in the future too. But they're not as fast as recent Blake 3 algorithms. Probably we need to support Blake 3. But I think these stuff, even MD5, we still need to implement them, because there are a lot of programs that are using them. We cannot let people to re-implement MD5 because there's no point. Just all the people just re-implement MD5. C++ don't have deprecated feature. We can just mark that deprecated, and people know all that they're deprecated instead of using it. Because if you're in a situation you need to support these old legacy systems, you have to deal with it. Probably in 3DS we already need to support it too. What a random number generator. Random number generator is a white-hole device. It's RTL gen random on Windows, and they are random on POSIX platforms. You might say, why we're not using RDC instructions? What I find is that it's recently bugged on these latest AMD CPUs. It always returns -1. That leads to vulnerabilities. So these instructions might be bugged. If they're bugged, we cannot use them, right? It just, if always returns -1, that's just ridiculous, right? It's always, you can predict the output is deterministic, right? No, right? It's just a serious vulnerability. So RDSED instructions should not be used. Neither RD or NVIDIA. Networking supporting. I'm rewriting networking. First I used to provide networking, but I want to re-implement the crypto first, because async DNS is clear first an issue, because DNS. These DNS libraries don't provide async DNS. POSIX is not mainly supported on all libcs. If you want to provide async DNS, you have to deal with that, right? If you just doing with DNS with synchronized I/O, but you also want asynchronous I/O, then you have the DNS issues, right? You cannot just create a thread for it. So we need to async. I want to just first implement crypto and support DNS, and we need to use a DNS over HTTPS to ensure cryptography. Process. I used to provide process too, but I'm rewriting this because the reason is that creating a process is extremely hard with NTC's calls, and Win32 does not provide functionality for this. From React OS sources that they require 2,000 lines of code just to create a process on user space. And it requires 300 lines of code. With Windows XP's leaked source code, I actually have leaked source code with Windows XP. It's very tricky. It's extremely tricky to implement them with the code. Also, I'm thinking why the threading should also be rewritten too, because even on Linux, it's the same thing. Because Windows uses the same API set for both processes threading, and Linux still have the few tags, and they also work both for threading and Windows. And you have clone, you have tasks in the kernel space. Process threading are the same. It's just different for these kernel scheduler, CPU scheduler, and we have to think about it. There's currently no plan on how to deal with inter-process communication. Okay, I have no plan. Probably gonna do, but just basically first deal with these issues. The GUI debugging. So GUI debugging is that you have a lot of environment, particularly with this Windows environment. People don't use terminal. They use the develop GUI applications developing their games, and in that kind of environments, I think I should provide that hello world box. So in that kind of environment, you cannot use that, right? You have no terminal, but you still want to output something. So what we can do is this, using this box device. Okay, so it can output things directly to the as a dialogue, you know, which is very like basic what the Visual Basic was doing before, right? So it allows you to output things. You cannot input things, just output things, basically just for debugging. And if you want to ensure you don't have things, you can just debug or print it. If you put undebug here, and it will not work. Okay, it tells you the compilation will fail. No, the nd debug, right? No debug, right? It tells you the function don't work, right? So if you want to ensure your code don't leak to the final code, you always use debug print. So here we print hello world. We can print things to the debug print. So this is for GUI debugging. Box can implement differently on different platforms. If your platform does not support the GUI debugging, then it will use the standard the out as the device. You know, it's still out terminal, which is basically mainly targeting Windows, but we want to do it in a cross-platform way. Particularly developing with WinRT, for example, let's talk about CPU WinRT, Qt, MFC, VC WinRT, and OpenSLBIO. So besides this POSIX5C file, FastIO actually provide other file types like MFC file, Qt file, and BIO file. The design with the SAM method, basically the SAM interface, SAM layers, and it allows you to talk. Now you can just talk with OpenSSBIO. You can transmit between them. You can talk with file above file with Qt file. If you're developing in a Qt environment, you can just now using standard library with it. So you can even output VCP WinRT H string Qt file, but I think Qt won't compile with VCP WinRT. And you know, the WinRT H string and Qt file, they're all using using 16-bit. They're also using Trust16T as the implementation. So they are using the FastIO's code CVT mechanism to do code CVT to ensure that works. OpenSSBIO is the most we will support it, and also MFC. So if you're developing in these environments, particularly these, everyone just creating their own I/O library stuff, right? It just tells you that the Iostream doesn't work. So they will work under the same interface, and you will be able to output them under with FastIO. So the issues with FastIO currently, the largest problem is of course Iostream. It just sucks, right? Even through exceptions, it's basically denial of service. You know, just making one very hard to design APIs. So I hope we can have an obsession as compiler that supports obsession, right? So we can just ban the exceptions forever, and we can design nonsense forever, and we can design the library with the new obsession mechanism. Sequence module is poorly designed point. I cannot put library in the module poorly. Compilation speed is problem. Of course, nowhere as fast as Rust, I mentioned before. But I want to be as fast as STDIO. It's a big future works, basically issues with FastIO. Of course, there's a lot of functionality that I haven't implemented. Basically, they are because of these two problems. You know, these are two major problems that lead to other problems. So I'm not basically working more on cryptography part because it is something I can do before this stuff can get implemented. So of course I'm welcome to contribute code because you know, this need a lot of work, right? Even sound I need a lot of work. We need a lot of work and I hope we can make it work, you know. So I'm welcome to share, to contribute code, because if I myself cannot deal with all the, it requires a lot of knowledge in all areas, just not single areas. It requires some mathematical knowledge, it requires physical messages, basically a lot of messages. So if you have certain areas of knowledge, please contribute. So okay, let's let them aside. Finally, before we end, I think we can show something which is probably you're going to be very interesting. How Facile can work in CPP run, C++ runtime or Qt. So let me show whether I can show the Windows runtime. Okay, I think we don't have time to do this. So probably can, because I haven't created a project. But you can see Facile provides that kind of functionalities. If you want to use that, you need to use the Facile driver and this CPP WinRT. So you use the H string as an implementation of the Qt file. We have the Qt OpenSSL BIO. OpenSSL BIO provides a lot of functionalities. Okay, we can try this instead of trying the Qt stuff. I think we can try this. It's also very interesting. Here we add the final thing we want to show. I want to show you, which is how Facile do cryptography, how Facile deal with OpenSSL. So we can either use OpenSSL implementation or using Facile's implementation. The Facile's SHA-215 implementation is actually performed pretty good, but it's not very good for SHA-55, 5012, right? So we have SHA-215, and what we can do is I have a Windows XP. Right, we have Windows XP installation. We just calculate the SHA value. I hope the value don't. If it fails, it's just very easy. Okay, we need to calculate multiple times because first time the computer, when you try to do that, it doesn't load actually loading. So we can just try OSSL. OSSL probably not working. I need to create that console because I didn't compile. So it works for OSSL, and you can also use Facile with cryptography, and it actually using the instructions to do this, the SSE, the SHA intrinsic to do it. So you can just calculate SHA value with it, and yeah, that's basically the entire library is working. And yes. Thank you for watching this video. I think it's very long, 2 hours. Thank you for watching this video, for wasting all your time on this terribly long, horrible video. Okay, if you have any questions, you can leave your comments under the comment section. I think finally we can show you our Discord. If you want to join Discord to ask me questions. You can join this Discord. Yeah, Discord. I will put the entire slides as public. So preview design. Yeah. So if you want to join Discord, you can just join this Discord. If you're Chinese users, you can use this QQ group, right? You can also join QQ, right? You can just ask me directly. I'll make another video with Chinese to explain these issues. This is first is to explain to Western users for the problems, and we can make another video on with Chinese. Okay. Thank you for watching this video.